Welcome back to our discussion about the graphs, the attributes of the graphs of polynomial functions. And in this video, we are going to discuss the relationship between the degree of a polynomial and the maximum number of turning points that it has. So if we're going to talk about turning points, it kind of makes sense that we probably need to know what a turning point is. And a turning point is nothing more than a location or a point on a graph where the behavior changes from increasing to decreasing or decreasing to increasing, vice versa. Okay, so anytime that happens, we label that a turning point. I have some visuals here of graphs that you have come in contact with before of polynomial functions, and they're pretty well known. So let's look at them and kind of see a pattern. Okay, so we know that this is a linear function, and a linear function has a degree of 1. Now, tell me how many turning points you see here. Now remember, turning points where a graph changes from increasing to decreasing or vice versa. And so hopefully you said none. There are no turning points here because this graph is a strictly increasing graph. It doesn't change at all. All right, well, let's look at another one. This is a quadratic function, and we just spent some good amount of time talking about quadratic functions. And we know that the degree of a quadratic function is 2. And if you look at this graph, you can see that it's increasing here until we hit the vertex, and then it's decreasing. That means we have exactly 1 turning point here. How about a cubic function? Well, let's see. We know a cubic function has a degree of 3. And if we look at this function, we're increasing, and then we're decreasing, and then we're increasing again. So we have a turning point here and a turning point here. So we have 2 turning points, right? And we'll look at one more. This is a quartic function, okay? This one you're probably less familiar with. It's an M-shaped graph or a W-shaped graph. But a quartic function is a 4th degree function. You can probably see that there's 1, 2, 3 turning points in this quartic function. Okay, so I want you to look at the degree and the number of turning points in the graphs that I've chosen. Okay, and you should see a pattern here. This pattern holds for all polynomials with some restrictions. Okay, so what we say to generalize this is that a polynomial that has a degree of n will have a maximum of n minus 1 turning points. Okay, so a 5th degree function can have at most 4 turning points. That doesn't mean it will have all 4, but it can't have more than 4. Okay, so that allows us to look at the equation of a function and say, I can tell you what the maximum number of turning points are in this particular function. So let's look at these 3 examples. I have 3 different functions here, and we want to determine first the degree of the function and the maximum number of turning points. Okay, so if I'm looking at this first function here, what we want to think about is what would be the highest degree if I were to multiply all of this out. Remember, I can write this as 3 times x minus 5 times x minus 5 times x plus 4 times x plus 4 times x plus 4 times x plus 4 times x plus 4. And we don't really want to write it that way because it's really long and cumbersome. But if I were to multiply that all out, what I can think about is how many times would I multiply x together maximum? Okay, so I would multiply x together twice here, right? X times x, and 5 times here. So x times x times x times x times x. But then when I multiply these 2 things together, I would have a maximum of x to the 7th power. I've got a power of 2 here and a power of 5 here. So I would have a 7th degree function here. All right, so the maximum number of turning points would be 1 less than that. And we don't know if it's going to have all of those, but we know that it can't have more than that. All right, so how about this next example? It's similar. I can tell you right now I've got 4 x's right here, And then I've got 3 more that come from this factor being cubed. And I've got 4 more from this factor being raised to the 4th power. So my degree of this function is going to be 11. And then the maximum turning points, that will be easy. That will just be 1 less than that, 10. This last example is a little bit different in that it is not in factored form. So it's already multiplied out. We are just looking for the degree of this function. Now, I have done something a little tricky. I need you to look carefully at this function. I want you to find the degree of the function. Okay, so look carefully, and hopefully you said that the degree of this function is 5. I did not write it in standard form. Okay, so I want you to remember that when you're looking at a function, it is the power of the leading term if it's written in standard form. Otherwise, it's just the highest degree that you find throughout the function when it's all multiplied out like that. And so the maximum number of turning points here will be 4. This is a pretty easy concept. It just takes a little bit of practice. And so that wraps up this video, and we will pick back up and talk a little bit about the rational zero theorem. I will talk to you then.